the executive director of the Earth System Initiative here at MIT. And I'm very happy to be co-sponsoring this talk by Dr. Hansen with Fossil-Free MIT. And I'm particularly proud of helping to support this student group in its efforts to bring awareness and action to the threat of global climate change. Now, the Earth System Initiative is an independent research center, a collaborative, if you will, of faculty who are like-minded from across MIT and who view the Earth as a single integrated system. So climate, oceans, atmosphere, land, water, life, and people, all for one and one for all on our one planet. So I like to say that ESI is about the science of living on Earth. And by that I mean not just the science, the engineering, the policy, the planning, the business, the philosophy, and the art of living well on Earth. Of fulfilling our Darwinian responsibility to thrive as a species by taking full advantage of our incredible capacity to understand and to do with enlightened self-interest, the mens humanus, which is what MIT is all about. I believe that if we truly understand what constitutes sustainable human welfare and act to preserve that, then we will, as a matter of course, be taking care of the planet as a whole. So with that, I'd like to actually introduce now one of the officers of the student group, Fossil-Free MIT, Jeffrey Super.
Thank you, Kurt, for a very kind introduction. So my name is Jeffrey Supan. I am a PhD student here at MIT and a member of the student group organizing tonight's event, Fossil-Free MIT, co-sponsored by the Earth System Initiative. So again, I'd like to thank you all for braving the rain and coming out here for this incredible treat, listening to Dr. Hansen here tonight. Before we invite him onto the stage, I want to take this one moment to propagandize you while I've got you all as my captive audience to tell you a little about our group. So Fossil-Free MIT is a student group made up of everyone from freshmen through to faculty, really brought together by a shared concern for the burgeoning dangers of climate change, and in equal measure by a shared sense of opportunity to rise to meet this occasion. A chance to stand up for science, a chance to be part of something bigger than ourselves, and a chance to lead from the front and inspire a next generation of climate change heroes. Of course, as we all know here at MIT, when it comes to renewable energy research or climate science, we really lead the way. We're a trailblazer. But we have a problem, because while MIT is fighting climate change with one hand, it's feeding it with the other, investing hundreds of millions of dollars a year in the fossil fuel industry. This is an industry whose fundamental business practice is incompatible with the science of climate change mitigation. This is an industry that spends $500 million a year lobbying in Washington against climate change action legislation. And this is an industry that has funded anti-science disinformation campaigns that confuse our public, that sabotage our science, and that slander our peers. In response, Fossil-Free MIT has joined an international climate change movement spanning more than 560 institutions across the globe. We are calling on our leaders, our leadership at MIT, to divest or de-invest MIT's $11 billion endowment for the fossil fuel industry. Our petition has been very popular. It's been signed by more than 2,500 MIT members so far. That includes 1 in 3 of all undergraduates here at MIT. And we've been in ongoing negotiations with MIT's executive committee and administration since early last summer. If you'd like to sign the petition, we'll be passing it along in hopefully an organized fashion throughout the talk. But of course, this campaign isn't limited just to MIT. Everywhere I look, I see momentum building. Just last Thursday, 113 Harvard faculty wrote an open letter to their president calling for divestment. And 30 minutes later, Archbishop Desmond Tutu joined the cause. The day before yesterday, Robert Redford, of all people in LA, announced that Pitzer College was divesting its endowment from fossil fuels too. So there's something very special happening all around us here, and we invite you to be part of it. With that, it gives me great pleasure to introduce Dr. James Hansen. Dr. Hansen is Adjunct Professor of Earth and Environmental Sciences at Columbia University, and for 32 years directed the NASA Goddard Institute for Space Studies. Since the mid-1970s, Dr. Hansen has focused on improving our understanding of human-caused climate change. He is well known for his testimony to Congress in the 1980s, which helped raise broad awareness of the global warming issue. Dr. Hansen is a member of the National Academy of Sciences and was named one of Time magazine's most influential people on Earth in 2006. It would take me a really long time to list his other awards, so suffice it to say that in the words of Think Progress, he is quite simply the nation's most famous climate scientist. Last year, Dr. Hansen retired from NASA to focus more on climate activism. In that role, he has become widely recognized for speaking truth to power, and for his willingness to make personal sacrifices, having been arrested several times in front of the White House in protest of the Keystone Pipeline. Dr. Hansen has inspired a generation of climate scientists and activists, and today we are honored and delighted to welcome him as the 5th speaker for our Climate Change Speaker Series. He will be discussing with us the steps that the public, and especially young people, must take to tackle the climate crisis. Ladies and gentlemen, please join me in welcoming Dr. James Hansen.
Thanks very much. This title, I guess I agreed to this title. I think I initially had suggested a different title because a longer title, which is too long. But the point that I want to make with this longer title is that this is really an issue for young people. And unfortunately, the solution is also going to depend mainly on young people getting it. And the other thing that I want to make clear in this title is it's the problem with this climate change, global warming topic is that it always comes across as a gloom and doom story, and then people turn aside because they don't like to hear bad news. But it's actually not. If the issue is addressed sensibly, it actually makes sense and is actually beneficial, economically beneficial, as well as for many other reasons, preserving the other life on the planet. So we have to recognize that. But before I start on what I really want to say, let me just comment on a couple of things that are in the news. You hear that global warming stopped 16 years ago. In fact, if you look at this 12-month running mean temperature, it does give the impression that warming has been very little in the last decade or so. Even the five-year running mean, the red curve, the 11-year running mean, which is long enough to average out both El Nino, La Nina oscillations, but also the solar cycle, is still warming, although not quite as rapidly in the last decade. But this actually is not a surprise. And each decade, the planet is getting warmer. These 6 maps are the last 5 decades, and then the lower map on the lower right is the first 3 years of this decade. And each decade is warmer than the one before. And this decade is also going to be warmer than the one before. But the first 3 years are just about the same temperature. But you'll notice the Pacific Ocean has some significant region which is actually cooler than even the base period, which was 1951 to 1980. And that's a natural oscillation related to the Pacific decadal oscillation. But if you look at the temperature averaged over land, the red curve, in the summer, when the zonal winds are weak, then the temperature of the land areas responds more or less directly to the forcings, so that this Pacific cooling does not affect the continents very much. And you can see, in fact, that's what's occurring. The warming has continued unabated over the land areas. It's in the winter when the Pacific Ocean temperature has a global effect that you see cooling in the last decade. But that's an oscillation which is going to be reversed. And in fact, we know, the reason that we know that the planet is going to get warmer each decade is because it's out of energy balance. There's more energy coming in than it is going out, so it has to get warmer. The atmosphere has a very small heat capacity, but the ocean has a very large heat capacity, and so we can measure the planet's energy imbalance by measuring the heat content of the global ocean. And beginning about a decade ago, different nations cooperated in deploying more than 3,000 Argo floats around the world's ocean, which dive down to a 2-kilometer depth and measure the temperature, and then come back to the surface and radio the data to a satellite. And what we find is that the planet, the ocean is gaining heat. So the planet is out of balance by a substantial fraction of 1 watt per meter squared. So it means that there's substantial warming that's still in the pipeline, because the planet is going to warm up until it restores planet energy balance. And that means we've got almost as much warming in the pipeline as that which has occurred already. And one other comment about the weather, because this last winter has been really cold in North America. You notice the map for the temperature anomalies in the winter, or the map on the left. And then even March, again, North America is extremely cold relative to the rest of the world. Well, that's the weather patterns that's existed this winter. And some scientists are trying to decide, is this related to the Arctic warming? But if you look at the last 9 years, you will see that some winters, the unforced variability in the winter is really large. It's about 4 times, at middle and high latitudes, it's about 4 times larger than it is in the summer. So compared with the global warming, which is about 1 degree Celsius, about 0.8 degrees Celsius, and it doesn't vary much. It's slightly larger in the winter than it is in the summer. But the standard deviation is like 4 times larger in the winter. So we're not yet at a point that a given season, even averaged over the whole season, is going to be warm everywhere, because the standard deviation is larger than the warming. And it so happens that North America was very cold this winter, but if you go back 2 years, it was extremely warm. And the sea ice was just as reduced then as it is now, so I'm not sure we can make a connection with that, but maybe there is. But that's sort of a detail. Okay, now for what I really want to talk about, the climate impacts of this warming. You may wonder, why is 0.8 degrees Celsius warming important? And the additional warming that's in the pipeline. Well, the 2 things that I'm most concerned about are those effects that are irreversible on any time scale that we would care about. And one of those is ice sheet disintegration. It takes tens of thousands of years to build up an ice sheet from snowfall piling out. And so the danger is that by the ocean getting warmer, it's going to cause the ice shelves to melt. And the ice shelves buttress. The ice shelves are the tons of ice that come out into the ocean. And they buttress the ice sheet. And if the ice shelves are gone, the ice streams can then discharge ice to the ocean much more rapidly. There's a danger that we could get rapid disintegration of ice sheets and sea level rise of many meters. Species extermination is also irreversible. And there are other practical effects. But first, let's talk a little about the sea level. Sea level has begun to rise. It's now rising 3.2 millimeters a year, which is a bit more than a foot per century. So it's more than a nuisance, especially for islands and places like Bangladesh, Louisiana. But it's not what could happen. And if we look at Greenland, we see that the area that has melted in the summer fluctuates from year to year. We began to make measurements from satellites in the late 1970s. But although the weather fluctuates from one summer to another, there's a substantial trend toward larger area melting. That meltwater will go to a low spot on the ice sheet, burrow a hole in the ice sheet all the way to the base of the ice sheet, and it lubricate the base of the ice sheet and speed up the discharge of icebergs to the ocean. And we see that happening, although, as I mentioned earlier, the main mechanism is actually the melting of ice shelves, I believe, is the biggest concern. But now, beginning about a decade ago, we have these gravity satellite measurements, which measure the gravitational field of the Earth so accurately that you can see changes in the mass of the ice sheets on Greenland and Antarctica. And we see the seasonal cycle of snow piling up in the winter and melt in the ice sheet disintegrating in the summer. But also we see a downward trend in the mass of both Greenland and Antarctica. And in fact now, with the recent update of this data, you see that the last 3 years, the rates of mass loss from Greenland have increased substantially. It's now getting close to 500 cubic kilometers per year. But we don't know how fast, how much faster that rate is going to become. But we can look at the Earth's history. And the last time that the planet was significantly warmer than the current Holocene interglacial period was the Eemian, when the temperature was about 2 degrees Celsius, global average, warmer than the pre-industrial temperature, which means about 1 degree Celsius warmer than the present temperature. And sea level was at least 6 to 8 meters higher at its peak. In the talk that I'll give tomorrow, specific department, I'm going to argue that the end of the interglacial it probably was about 8 meters higher. But obviously, we don't want that kind of sea level to occur. Every coastal city would become dysfunctional if you had that large sea level rise. There's some parts of the city may be out of the water, but it would be dysfunctional. And so the ice sheet response time is uncertain, but we know that it's shorter than the lifetime of the carbon that we're putting into the system. So it doesn't make sense to put enough there that guarantees you're going to get sea level rise of many meters. And I will come back to that a little bit. But now for species extermination, there are many things that we're doing to put stresses on different species. But if you combine those with rapidly shifting climate zones, then there is a danger that we could drive a significant fraction of the species on the planet to extinction. And climate zones are shifting. You have to average over a number of years to get smooth lines, but they're shifting on average by a few kilometers per year, which will become a major problem for many species, and already is beginning to. And I'd like to use this specific insect as an example of the stresses that we're putting on species. Because like most of the others, there's some other cause which is particular stress. In the case of monarch butterfly, which is a remarkable insect, it does this annual migration from a small area of fir trees on volcanic mountains in central Mexico all the way to Canada, and then the eastern monarch then comes back down to Mexico and hibernates on these, finds its way back through the same small area in Mexico. And it actually takes 3 or 4 generations of the butterfly to make that round trip, but somehow it's able to find its way back. But we notice, when my wife and I were younger, we noticed on our property in Pennsylvania that we could see 10 or 12 monarchs at the same time. Now, you normally don't see any, or you might see one, or 1 or 2. But anyway, I like to introduce my grandchildren to nature, and this seemed like a nice thing to do. We would plant. So by the way, so the stress on the monarch is that the herbicide Roundup that farmers use to kill weeds is killing milkweeds, and therefore, and that's the only food that the monarch larvae, the caterpillars, can eat. And so the number of monarchs is decreasing as the milkweeds decrease. So we plant milkweeds on my 8-acre farm. And this particular broken wing female was, I noticed 3 years ago in the summer. That was the summer that there was a tropical storm that came up and dissipated on the East Coast, but it dumped a lot of water, and our rain gauge overflowed at 6 inches. And I was off in Washington, D.C. After I'd taken this photo, I was off in Washington, D.C. getting arrested. But when I came back, I thought, this monarch, so she had been flitting around our yard, the only one, for several days. I came back and thought, well, she wouldn't be there. But she was still there, flitting around. And also the caterpillars had started growing, so she produced about 30 of these caterpillars. She was the only butterfly for several weeks there, and apparently decided she wasn't going any further. And at one moment here, you can see 2 butterflies emerging from their chrysalis at the same moment in our privet. One of them was this male, and one of them was this female. And so then we were wondering, are these butterflies going to make it to Mexico? Because they had to go through Texas, and Texas had a tremendous drought that year. And I wrote an article about that broken-winged butterfly, and a Mexican scientist wrote back to me and sent me some photos. This is a branch of one of the fir trees where monarchs were roosting, and that's his grandson looking up at the butterflies. But what he saw, in addition to the butterflies, was the fact that these trees are under stress because there's been a drought for several years in Mexico, and so he is trying to persuade the Mexican government to plant these trees higher up the mountain, where the temperature and precipitation are more appropriate. But then the count of butterflies that made it that year was reduced 30%. And the next year, there was a drought throughout the Midwest, which is even bigger. And the number was reduced a further 59% that made it to Mexico. And then this last year, the weather was fine, actually, but I only saw one monarch on our property, and I took a photo of that monarch, and I was wondering, this monarch was hanging around our yard for a few hours. You know, he landed, we have this nice butterfly bush to attract them. We have all these milkweeds planted for them. And he landed on the milkweeds briefly and on the butterfly bush, but he got chased away by these big yellow butterflies. I forget what they're called. But you know, he landed in the grass several times. He flew over the barn. He came back and landed in the privet bushes. And so I wonder, why doesn't this butterfly lay some eggs on the milkweeds? Well, when I got inside and looked at the photo, I saw that it was a male. So it wasn't going to lay any eggs on milkweeds. But you know, these butterflies don't travel in pairs. When I was a boy, when the moving cranes almost went extinct, we got down to just about 20 or 22 of them left on the continent. It was possible to get their numbers to go back up. Then the U.S. passed laws that you can't shoot a moving crane, a big fine and things. But those birds traveled in pairs or in groups. Well, the monarchs don't do that. So I think my suspicion is that male was looking for, you know, they fly like 50 miles in a day. But then he comes down to get some nourishment. And also, I think he is feeling frisky, is looking around. He never found a female. And so I'm afraid that they may. And what happened, despite the good weather, the numbers went down again by almost half. So I am afraid that the number may be below the number that can survive, but we will see. It is highly variable. Anyway, that's just one instance. Coral reefs are the site for more than 1 million species. They're the rainforest of the ocean, and they are under stress because of the warming of the ocean. On the warm years especially, the coral will bleach and expel their symbiotic algae. And the acidification of the ocean is another problem, and other things that we're doing around coral reefs. So we're losing more than 1% per year. It's a big threat to life in the ocean. With regard to regional impacts of climate change, those are the things that people really notice, the changes in heat waves, droughts, and fires, and floods, and heavy rainfall. Well, we are affecting regional anomalies, and we can these graphs are showing the distribution of summer average temperature anomalies starting last century, using 1951 to 1980 as a base period, and then there's looking at all land areas, there's a variability, natural variability of the summer and winter temperatures, and here it's plotted as a function of the standard deviation, the local standard deviation, and so you get this nice bell curve. But now that bell curve is shifting because of global warming, and that means that what was considered to be an unusually hot summer and occurred, a 3 standard deviation anomaly last century occurred only a few tenths of 1% of the time. But that same temperature anomaly is now occurring more like 10% of the time in the summer because the bell curve is shifting to the right. This is global warming. And you notice, by the way, in the winter, that the shift is not as much because it's measured in the standard deviations, which is, although the winter warming is slightly larger than the summer, because the variability is so much larger, you don't see that effect. So it's very unlikely that you'll get a summer that you considered cool in 50 years ago. But it's not so unlikely that you'll get a winter which you think is unusually cool. And these, there are fires, the higher temperatures, when you do get a high pressure system stuck someplace for a while, this higher temperature is going to cause more rapid evaporation, and I need to push this green button, this energy-saving power connection. And the fires are burning hotter, and we see in the statistics, you know, when you do get a wet year, then you get rebuild the fuel. And there is enough data on precipitation to see that because the atmosphere, a warmer atmosphere holds more water vapor, we expect when you do get rainfall, it will tend to come in more extreme events. And there is sufficient data to confirm that in fact that's happening. And so 100-year floods can now occur more often than once a century. We would think that storms that are powered by latent heat of water vapor have the potential to be stronger in a warmer world, because the atmosphere holds more water vapor in a very nonlinear fashion. And that means thunderstorms, tornadoes, tropical storms all have the potential to be stronger. And I don't think we can confirm that that is in fact happening yet in as convincing way as we can with temperature and overall rainfall. But it's clear. What is clear is that we can't burn all of the fossil fuels. What we've burned so far is the purple parts of the conventional oil, gas, and coal. And we've already we've already burned most of the carbon budget that we can afford to. We published a paper a few months ago in which we argued that the limit should be of the order of 500 gigatons of carbon. And we've already burned 370. And if we kept it at 500, and if we took steps to improve agricultural and forestry practices so that we stored more carbon in the soil, and we restored some of the deforested areas where it's marginal land that's not really useful for agriculture, then we could stay close to the Holocene. But, actually what a lot of people are talking about is a 2 degrees Celsius target. Well, I would argue that's actually a disastrous target because that's the ambient temperature. And we know that there's just a one-to-one correspondence between sea level and global temperature on long time scales. So you would have to anticipate, if you have 2 degrees Celsius warming, that we would have sea level rise of multiple meters. We can't say exactly how rapidly, but we would guarantee if it's not your generation, it's going to be your children and grandchildren. It's not going to be millennia. If you look at the temperature curves and the sea level curves and the CO2 curves on the paleo record, they're practically congruent. They're just too close to each other to see a lag. So it's not millennial. And so it doesn't make any sense to guarantee that some future generations have problems which are practically unsolvable. So we really need to phase out coal use. Coal is used mainly for electricity generation. There are other ways to generate electricity. And we should not go after all the unconventional fossil fuels. There's a tremendous amount of carbon in if we're going to frack to get coal and oil, and go after the tar shale and after the tar sands. There's an enormous amount of carbon, but it doesn't make any sense to do that. But what's really happening is just that. You know, even the governments that say we have a planet in peril are advocating more fossil fuels for energy independence. Doesn't make sense. And as a result, the carbon emissions are actually accelerating. Instead of turning around and beginning to phase them out, we're using them faster and faster. The problem is that to the consumer, fossil fuels seem to be the cheapest energy. And they seem cheapest because we don't force them to pay their cost to society. In fact, we partially subsidize fossil fuels in several different ways. And we don't make them pay for the human health effects of air pollution and water pollution from fossil fuels, which itself, if we would just add that cost, it would make a huge difference and we would start decreasing fossil fuel use. But we don't do that. We make, if your child gets asthma, you pay the bill. The fossil fuel company doesn't have to pay that. And the climate effects, which are already beginning to occur, but which the huge ones are still in the future. But those are also either if the government comes to your rescue after something happens, well, the taxpayer is paying or you just pick it up yourself. So we need to have a carbon price, and not a cap and trade with offsets. The hokey idea that the Kyoto Protocol is based on. Emissions were going up 1.5% per year for a few decades until the Kyoto Protocol, and since then they've gone up 3% a year. So it's not an effective way. You've got to actually make the fossil fuels price rise. And the way we should do that is collect money at the source so that it covers every use of the fuel, direct and indirect. That means at the domestic mine or the port of entry, you collect a fee from the fossil fuel company, which would rise over time so that we have time to make the changes in our technologies and in our personal habits. And that money should be distributed to the public so that they would have the wherewithal to make those changes. And if in that way, if you give an equal amount to every legal resident of the country, then the person who does better than average in limiting their fossil fuel use would make money. With the current distribution of energy uses, 60% of the people would get more in their dividend than they pay in increased prices. But they would need to pay attention to prices if they wanted to stay on the positive side of that ledger. And everything would be affected, whether it's food prices. So food that's imported from New Zealand would begin to cost more and more, but the nearby farm would be favored. And that's just one example. That would stimulate the economy and put money in people's hands. It's what we need to solve the fossil fuel addiction. You know, even by the time, if you have $10 a ton and going up $10 a ton, by the time you get to 10 years, the economic models show that would reduce our fossil fuel use 30%. And that's 10 times more than the amount of fossil fuel carried by this huge Keystone XL pipeline. So it makes much more sense to do something like that than to try to find more and more fossil fuels. And this, I think, is the only viable international strategy. You can't sit around a table with 180 nations and argue that everybody should have a target to reduce their emissions. That's simply not going to work, especially when some countries are not responsible for the problem. They're going to say, why should I reduce my emissions? You caused the problem. So if we have a fee on carbon, then all it really requires, ideally both the US and China would agree that they're going to have a fee. And China has reasons to do it, because they have a huge pollution problem. They will suffer more from climate change than just about anybody. They have 300 million people living near sea level. They don't want to be addicted to fossil fuels the way we are. So they actually are willing to talk about having a carbon fee. It's the United States that's the problem. But if China and U.S. would agree to have a carbon fee, then they can say we're going to put a border duty on products from countries that do not have an equivalent carbon fee. And that would be an enormous incentive for other countries to have their own equivalent carbon fee, because then they can collect the money themselves rather than have us collect it in our borders. And so you only need the major players to agree to do this. And I've already said that. But you do have to have, it's not enough. This will spur technology development, but we do need energy. This is what global energy consumption looks like in a percentage term. It's mostly fossil fuels, more than 85% fossil fuels. And the renewable energies, other than hydro, are barely visible on this kind of graph. That's also true in the United States. And in the United States, I can include the wood because there's data from the United States, at least estimates. But the same picture is true, except we're using 20% coal instead of 30%. So unfortunately, the strategy which all environmental groups all the big environmental groups are advocating and insisting on, and I think you young people had better understand this pretty soon, because you're the ones who are going to pay the price. But I've been meeting Amory Lovins at meetings for the last several decades, and I really like. He's extremely bright fellow who and a very good salesman, and he's been extremely effective in emphasizing the importance of energy efficiency, which is the first thing that we should pay attention to. That's obvious, because every energy source has some bad things about it. There's nothing free. So the best thing to do is figure out how to get what you want using less energy. And he maintains that we don't need oil, gas, or coal. We don't need nuclear power. We don't need large hydro. And we don't need a carbon tax. And and he had this in the 1970s. He set up this vision for what was going to happen. That by means of energy efficiency, this is for the United States. By means of energy efficiency, we would reduce our energy requirements. And he's absolutely right that energy departments always say we need to increase our energy use. And you see the energy department projections were way too high. And then even when they reset and make a new projections after they see that it really wasn't necessary, then they still project too high. But we do need energy. And basically, the United States energy use has flattened out over the last few decades. It hasn't really, because we partly shipped overseas the production of many products that we use. So our actual energy use has still been increasing. But there is potential, untapped potential in energy efficiency. And Amory argues that you can solve the whole problem with energy efficiency and renewables. And he says that the industry is leaving $100 bills lying on the floor. They're just not taking advantage of the potential of energy efficiency. Well, in reality, what he saw as taking over all the energy requirements is still just 3%. It's not really visible. The green that is occurring is mostly hydro. So I would get him to agree that, well, carbon price would help. I can't understand why he won't at least say we need a carbon tax, except that one reason he's so popular is that he says everything that people want to hear, that you don't need anything bad. You can do, and so even though sometimes he'll privately say that would be useful, but then still in his public talks he doesn't say we need a carbon tax. So what's happening is emissions are going up faster and faster. Can they be decreased rapidly? France, in one decade, increased its nuclear portion of its electricity from 8% to 70%. And Germany is trying very hard to do renewables. And they've increased renewables now to about 21%, I think. But you know, what we have to do, basically, is decarbonize the energy supply, one way or another. It can be renewables, or it can be nuclear power. Maybe there's something else. But if you look at the carbon intensity and how well different nations have done, the one nation that has done the best by far is Sweden. They completely decarbonized their electricity, which is about half hydro and half nuclear. And so they're really close to what we need to do. They still need one more step, and that is to produce liquid fuel from electricity, which you can do. As the price of oil gets a bit higher, that will make sense. So you shouldn't expect a small country like Sweden to develop technology for the world. But it's actually not, it's actually possible now to make liquid fuels from electricity. So then they would essentially decarbonize their. And France was not bad, although they drive a lot and their electricity is not totally fossil fuel free. And both of those countries made the change on the time scale of the order of a decade. So even though people say, oh, you can build a windmill or a solar panels much faster than you can build a nuclear power plant, well, in the United States, that's certainly true. We've made it so difficult to build nuclear. But in fact, in terms of how fast you can move to carbon-free electricity, we have not been able to do that with renewables. And what I find disconcerting is the fact that the environmentalists have pushed the Democratic Party so hard that they essentially say we have to eliminate nuclear power. And so they got Bill Clinton in his first State of the Union message to say we're now going to terminate all research and development in nuclear power. And that was at a time that Argonne National Laboratory was ready to demonstrate a fast reactor where you know, the current nuclear power plants, which you should not build any more of, they burn less than 1% of the energy in the nuclear fuel. And they leave the rest of it in a waste pile, which has a half-life of more than 10,000 years. So you have a babysitting problem forever. But you don't need to. With fast reactors, you can burn more than 99% of the energy, and you can, in effect, burn nuclear waste that we have, and you can burn excess weapons material. Well, I'm not particularly in love with this fast reactor that Argonne is advocating. I think it has a number of features which make it much superior to prior technology. But there are other ideas out there, some of which are very promising, like thorium reactors, and any of the new reactors should shut down automatically in the case of an earthquake or other anomaly. And they should be able to cool themselves without any external power. That was the problem with Fukushima. It lost its external power because they had foolishly put it in the basement. And they had put the used fuel in the attic. If they had switched those around, it would have made some sense. But in any case, you shouldn't build that nuclear power plant again anyway. But and so if you have fast reactors, then nuclear becomes an inexhaustible source of energy. You can sieve from the ocean uranium, which at a rate which will allow you to have energy for billions of years. It's leached out of into the ocean fast enough for that. But in any case, here's the problem. What causes the climate change is not current emissions. China has shot past us, and they're now almost double our emissions, and still increasing. But what causes the climate change is not today's emissions, it's the cumulative emissions, because the carbon will stay in the surface system for millennia. And the U.S. is responsible for more than 26% of the excess CO2 in the atmosphere, while China is only responsible for about 10%. They have 4 times as many people. So there's a factor of 10 in cumulative emissions per person. Actually, the United Kingdom is the leader, and we're just a hair behind them. Germany's at about the same level, and other countries like Canada, Australia, Russia are not far behind. But the developing countries like China and India, they're very small contributors on a per capita basis. So, and yet, so here we have this situation. So my vision is, I would agree with Ed Wilson. You know, we're putting pressure on so many species, and with the and it's because humans are basically taking over the planet. And our population is 7 billion. It's going to at least 9 billion by the middle of the century. But I think, but Wilson argues that, well, this century is a bottleneck, and we can solve the problem, but we will have to control the human population. But that's actually not so difficult. It may not be so difficult. If you look at all the developed countries now, almost all of them have a fertility rate which is less than the replenishment. And once you develop, so look at Japan, for example, which has almost no resources, natural resources. Their economy is just flattened out. But if you go to Japan, their lifestyle is great. It's a nice country to live in, and their population, their fertility rate their population is really going to decline. But in order to get to the point where you have that happen, where you start to have lower fertility rates, it seems to require you get to a stage where you're better off. And so you can't blame countries like China and India wanting to develop and get to a better lifestyle. But they have no option. We used fossil fuels to replace slavery, actually, but as a source of energy to become wealthy. And now we're telling China and India, well, you need to follow a different path than we did. So we're willing to help you with solar panels and windmills, but you really shouldn't burn these fossil fuels. Well, if that's their only choice, they're going to do it. Right? But there's actually an opportunity now because China is so choking under pollution from fossil fuel burning that they desperately want alternatives, and they don't have, because we made the decision. And I would argue it was Jimmy Carter and Bill Clinton who were responsible. We decided that we didn't want the world to develop nuclear power. And so they actually have no alternative for baseload electric power. It's not, I don't think it's too late, because there has been some technology progress percolating along, and there are some promising avenues. And it may be that it's not nuclear power. I don't particularly want to focus on that, because what should be making the decision is the carbon price. If we would put a rise in carbon price, then the market would make the decisions. We shouldn't. But what we do instead is say, oh, there's a renewable portfolio standard. Everybody's got to have 20% or 30% or whatever renewable energy. Well, what that does then, because the renewables are intermittent, then that one of the effects is to kill something with nuclear power, because what nuclear power does is work flat out and just run 100% of the time. We should, instead of deciding on the technologies, we should put a price on carbon. And we have the innovative potential to solve the problem. And one advantage that the United States has, we're at a point now where we're in danger of China just taking over and becoming the technology leader, because they are investing in all kinds of clean energies, solar, wind, and nuclear. And they're building them at scale, so they'll be able to drive down the unit price. But they could do it much faster, and they could do it with safer technology if we would work with them. It's really, we should be working with them. We have an obligation, because we put them in a position where we burned our part of the carbon budget, and then they started burning their part. And we've burned a large fraction of their part. So they're in a position where either they blow the planet's carbon budget, or that's basically the only choice they have. And so you see their coal use is just shooting up. So you really need to figure this out. And one idea, young people should be meeting with young people in China and helping to figure this thing out, because the old geezers aren't doing it. And it's a case of intergenerational injustice, because our parents didn't understand this, but we can only pretend that we don't understand what we're leaving for young people. One thing we can do is take the government to court, and we're doing that actually. There's one of the suits is filed against the federal government, basically asking the government to give what is its plan for reducing emissions at a rate that is required to stabilize climate. And that's the paper that we published in PLOS One last December is the paper that's the part of this legal action that defines how fast we would have to reduce emissions. And initially, the initial ruling in this case was against the young people, but I think that was actually for the best, because the case was filed on the basis of trust, the trust doctrine, that the atmosphere and climate are held in trust by the current generation, and we're supposed to deliver them to the next generation in equally good shape. And that's a good concept. It actually goes back to our founding fathers. Thomas Jefferson argued that we have to leave the soil in equally fertile condition for the next generation. But the court said, well, the federal government has established EPA to take care of this. At the same time, and so he ruled against the young people, but he did it in a way which invited appeal, because he said, but you haven't shown a constitutional basis for why this should be required. And of course it is. There is a constitutional basis. It's equal rights. It's just it's similar to civil rights, where our whole country is founded on the concept that all people are created equal, and they have, and the Constitution then says they have equal protection of the laws, and they can't be deprived. No one can be deprived of property without due process of law, and that's what we're doing. And so this case is going to be heard on May 2nd. This year, so in a couple of weeks, 2 weeks from tomorrow, I think that is. In any case, it's May 2nd, and I think it would be very useful if for a lot of young people would be sitting there when the judges. This is the most important court below the Supreme Court, in which this is being held, in the District of Columbia. And the courts have not been carrying up what was expected of them. They have done in the last few decades. And this is a case where we're trying to make clear to them that the courts really have an obligation, because the other parts of the government, the executive and congressional parts, are responsive to the short-term political issues. The court is supposed to have this longer view and should put some requirements on the other parts of the government. But I think perhaps the thing which makes me most optimistic is citizen climate lobbying, because I think we, it's harder to get our democracy to work the way it should work, because it's developed in a way such that money is a big driver, as opposed to one person everybody having equal influence. But it still is a democracy, and we can make it work. And this Citizens Climate Lobby has taken as its objective, its sole objective, this idea of a carbon fee and dividend. And they're growing in number rapidly, almost doubling every year the last few years. And they write letters to the editor and op-eds, and they visit their Congress people, and they visit editorial boards, and they're very polite in doing this. If the senator won't speak to them, then they talk to the staffers, but then they'll come back again. And so I think we may be able to make the system work, and I think there are some conservatives who are starting to realize that if they pretend that this is all a hoax, that they will, when it becomes clear it's not a hoax, then the public will demand action, and that allows the government to take over. It's the worst nightmare for conservatives. It gives the government more authority to take over their lives. So anyway, I think I better stop and we can have Q&A at this time. Sorry, I took a little longer.
Thanks so much to Dr. Hansen for that talk. Obviously, the focus of this climate speaker series is really to generate a fruitful discussion about how we can work to address climate change. So, if I can encourage questions, please line up along these podium mics here. My only stipulation would be that the question should last for about maybe 30, 40 seconds at most, and there should be a question mark at the end. And that would be like.
Dr. Hansen, thank you very much. It's a privilege to see you in person. Big admirer of yours, and in particular because I have joined scientific work with political work. And I have a sort of depressing question for you. What we're doing doesn't seem to be working in terms of convincing a majority of the American electorate that this is a problem. The surveys that are done show a reduction in the last few years, and I only have 40 seconds, so I won't get into the details, in the number of Americans who believe that action has to be taken. The numbers are going down. So my question is, are we doing the wrong thing? Are we not doing enough of the right thing?
Well, I think the issue has been converted to a political one, where conservatives feel that this will be used by the government to get bigger and to control their lives more. And I have some sympathy with them in that regard. So we have been arguing. I've gone in the senator's office and argued this. And when John Kerry was a senator, I spent 1 hour arguing, this cap-and-trade thing you're pushing is not going to work. You've got to have an honest, simple, honest carbon trade. And he said, you're right, but I can't get 1 vote for that. But anyway, we keep hammering on it anyway, because it does make sense. And we finally persuaded Barbara Boxer of that. So she introduced with Bernie Sanders the fee and dividend bill. But she wants 40% of the money. That again won't work. And that's just, and I'm sorry to say, I'm a political independent. I don't like either party. Because the Democrats want to have more tax money. And it won't work in that case, because the public will only push this and let it get higher the way it needs to if they're getting the money, and if most of them are actually benefiting. Then we'll have a push for it. But if it's just being used to make the government bigger, then it's not going to work. So I think, however, that we're not saying the wrong things, and I think that the public, if they were just given an accurate and honest statement of the problem, that they would support it. When Barack Obama was elected, and before he took office, I wrote a letter trying to explain this. He's got to put a fee on carbon, and that if he would do that, it would stimulate the economy, which is what he wanted to do, and everything. But I couldn't get John Holdren to deliver the letter to him. And putting it in the mailbox is not going to work. But when he had 70% popularity, he could have had fireside chats with the public and said, we need to do this. The price of gas at the pump is going to go up, but there will be, you'll have the potential to actually do better. And it is actually a redistribution of income, in the sense that low-income people tend to gain from this. If you have 2 houses and fly around the world a lot, then you will pay much more in your carbon tax than you get in your dividend. But you can afford that. And actually, rich people are not going to object to this carbon fee. It's nothing like an increase in the income rate, tax rates. So, so I think the problem is that we're telling the public, yeah, there's a climate problem, and therefore, you know, you've got to have solar panels. And by the way, I'm completely in favor of solar panels. My barn is covered with solar panels, and we generate twice as much electricity as we use. And they're part of the solution, but they're not enough. And for Democrats to pretend that all you need is renewable energy is a tremendous disservice. And that's why I think we need to get Chinese experts and U.S. experts together, and people who they really need energy, and they're willing to do any kind of thing that will work. But it's got to be real. It can't be fake.
Thank you so much, Dr. Hansen. I'm going to turn this into a question as best I can. If you are wondering how to join the Citizens Climate Lobby, there are representatives here today in the audience, and we will be down in the mezzanine after your talk. In addition, if you're wondering if any action is taking place on the state level, here in Massachusetts, I'm happy to say we have an extraordinarily visionary Senator Mike Barrett and a partner of his, Representative Tom Conroy, who have already submitted carbon tax legislation to the Massachusetts State House. And I'm going to jot this bill number down. It's H2532. This is for a revenue-neutral, statewide carbon tax, and they need your support. The Citizens Climate Lobby representatives can tell you how to get involved in that effort as well. Thank you.
Yeah, my answer to that question you know, we really need a state or a country to have a carbon fee and dividend. And, you know, it's easy to get someone to say, oh, we'll have a revenue-neutral carbon tax, and then they reduce some other tax. That, I'm afraid, is not going to lead us. That's useful, but it doesn't, we have to have this escalating carbon tax, and the only way to get that to happen is if the money is going to the public. And finally, you know, so the states that you think will be the most progressive, Massachusetts would be one, but California is certainly one. So they decided they're going to have a cap and dividend, a cap and trade. And I argued with the governor, and I said this was half-baked and half-assed in front of a big audience. And he was in the front row, and he laughed, and then we had a discussion later. And finally, I think he agrees with this, that they really should have done a carbon fee instead of a cap and trade. But we have to get someone to actually do that. So now, talking to Oregon and Washington, trying to get them to agree to do this. Because if somebody would show that this works and the public likes it, then we have the potential to go national and then go global. But without it, I don't see how we're going to phase out fossil fuels.
Hi, my question is, have you heard of a company called Cool Planet?
Pardon?
Cool Planet?
I don't, you have to explain it. So if that's what you want to say.
I was at the Renewable Energy Conference 4 years ago. They were a startup then, and that's how I found out about it. But they are making carbon-negative gasoline. They're just building a refinery in Louisiana, and they just got like $100 million in financing to do that. And so,
And what they need in order for that to take off is a carbon price.
right. So if I'm carbon negative, then I can get paid.
Yeah.
Sounds good to me. But to me, I've been an energy conservation auditor most of my life. This is the most hopeful thing I've heard about.
Yeah, I think that we have potential for tremendous innovations, and if we just have that price there, they would happen. And Massachusetts and MIT and California and some places would have a lot of things coming up, and the U.S. has the best universities in the world, and we have a system that encourages innovations, and we can still be world leaders and economically, but we have to stop. We have to actually not say that we're going to maintain it by coal. We've got to actually move to energies of the future.
George Bryant from Revolution Books. I want to further the conversation a little. I greatly appreciate you bringing the truth about the urgency of the moment. The UN is certainly doing that in their own way too. But there's also a truth about how the political power operates in today's world. And one quote kind of captures it from Barbara Bacon, that the essence of what's going on here is not democracy but capitalism. And these guys who in the driver's seat here are competing with other capitalists around the world, essentially. You mentioned one thing that really struck me, that not too much industrial production is going on here because they've shifted jobs other places. Why? Because they're chasing profit. And other powers around are doing the same thing. We need to have a broader conversation. How do we get to a different kind of foundation that isn't capitalist? How do we explore socialism beyond? The only thing I want to pose here, I don't want to have a debate with you about it, but I am promoting a Revolution newspaper that's inviting people to explore the potential to get this kind of revolution off the ground. Because the truth is, the current social order has not been responsive, cannot be responsive, and its political leaders, rather than facing the truth about this climate science, are absconding the truth. They're misleading, and someone like I said, like Obama, who has the capacity to reach people in their hearts, has done it with the wrong message, essentially. It's not because he doesn't know what you want to give in that letter. I'm just having some conversation. I'm not trying to open a debate.
Yes,
Just invite people to look at this.
Yeah, well, one of the problems with liberals is they think, well, we just have to change people's habits. Well, unfortunately, you go to these other countries as they're starting to develop. They want the same things that we did. They like the idea of a personal vehicle. They love it. So around Beijing, you've got seven of these ring roads, and you're not going to stop that. So as they get wealthy, they're going to do things that take energy. And so we better find some energy which is clean and which is carbon free. Because we can try to tell people to change their lifestyle and things, but I think we're going to have to find clean energy.
Well, I'm going to start my question with a statement that you may disagree with, but the statement is it's now widely admitted that global temperatures have not increased in 15 years. So is this because of the constant worldwide spraying of aluminum and barium particulate from passenger and military aircraft, often referred to as chemtrails or geoengineering?
No, actually the atmosphere is now, at least the upper atmosphere, is quite clean of particulates. Compared with natural source, aircraft particulates are not that big. But I must say that's one of my pet peeves or complaints about our failure to have in space an instrument that can measure small particles, aerosols in the atmosphere, because they are a significant climate force. The total of them, most of them are products of fossil fuel burning, not the sources you mentioned, but simply the fact that coal has a lot of sulfur in it, so you have the sulfates. And we're not measuring that with the accuracy that's needed to quantify and compare it with the effect of the greenhouse gases. And that's one of the interesting effects of that is aerosols have overall a cooling effect on the planet. And they partially but we don't have that problem quantified as well as we should because we're not making the measurements.
So is that why they're mixing aluminum particulate and barium in the jet fuel?
Well, that's just not a very big source of aerosols, but it's.
So they are doing it.
But I don't know. But
And you
it's
see the
not
big white plumes behind the jets. What do you
Oh,
think
sure.
those
So
are?
that's the big white plumes behind the jets is a condensation.
They're not condensate.
I think we'll explore that.
Dr. Hansen, I was just wondering about your analysis in the December paper of the annual reduction required for the 350 part per million stabilization scenario. You had a 6%, I believe, annual reduction rate as a global rate. Doctors Anderson and Bose at the Tyndall Center in the UK have done a disaggregated analysis along with some other people of the 2C 400 to 450 parts per million stabilization target. In their disaggregated analysis, taking the Copenhagen Accord principles at face value, results in first world and developing countries needing annual reduction levels of greenhouse gases of about 10 to 11%, actually, if developing countries peak their emissions at 1.5. What would the disaggregated rate, for example, the United States be year on year at a 6% global average rate? And is that even economically feasible through market-based mechanisms?
Well, you see, I think that what our 6% is under the we're not aiming for 2 degrees Celsius, but what would the temperature, if we actually follow the scenario that we define, the temperature would peak at about 1.2 degrees and then decline because we're trying to stay at close to the Holocene, which means about 1 degree above pre-industrial. But then chopping that up and saying, okay, this country's got to reduce more because it has, well, you can't do it that way. There's no way. We've already burned more than we would have to have a negative emissions from the United States. We've burned way past our share. So we have to find an approach which allows developing countries to have abundant, affordable, clean energy. Because they don't really want carbon. They don't really want to equal our carbon emissions. They want energy. And they would actually prefer clean energy over coal energy. So let's not try to divide that up, this small remaining carbon budget, because our share would be zero. Let's figure out a way, working together, to solve the global problem. And it's possible, but we shouldn't have our head in the sand and think that these wonderful solar panels and windmills, which I love, are sufficient by themselves.
Thank you for your work over all these years. First of all, to look at the politics, to look at the business, to look at the developing nations, you might want to look at Ramin Shakti, which is in Bangladesh and is on about 5 million households where we have renewable energy through their auspices that are in 2015. I would like to ask you about the U.S. annual energy budget and energy conservation or energy efficiency. I've looked at the Lawrence Livermore National Lab annual energy budget graphs going back to the 90s. And for about 20 years, we've been 100 quads, 95 to 100 quads every year. So we stabilized. But they changed the way that they looked at what they call rejected energy a year or so ago. Even with that change, what you see is that 54%, 56%, and this year 60% of the energy that we produce is what they call rejected energy, waste. So, do we have an energy problem, or do we have a waste problem?
Well, I think we need energy. You know, we actually need energy. We're going to need more energy in the future for desalinization. for recycling metals. We can't just continue to dig up everything. We need there. It would be nice if we could do. It is true we're wasting energy, but as soon as we figure out a more efficient thing, we find more ways to use the energy also. So in lighting, for example, we now have solid-state lighting, which is much more efficient than the old lighting, but then we use more of it. So as long as it's cheap, that's why we have to make the prices honest. But I think we're going to need energy, and I don't think it's impossible or even extremely difficult. We would just have the right incentives to develop that clean energy. So I think it's, and I've said it several times, I think efficiency is great, but it's not enough. We're going to need, and the developing world needs, abundant, affordable energy.
Thank you, Dr. Hansen. I want to say it's an honor to come here to speak. I've been reading pretty much everything you've written for years. I would ask a question about economics because I believe that climate change is really just a symptom of our economic system. But I want to get back to science here a little bit. I read a lot, and I'm concerned about tipping points. Specifically, could you talk a little bit about methane caltrates? And I know there's a lot of methane under the ocean, and my concern is that we don't know where some of these tipping points are. And what's your knowledge and your opinion of how that could possibly play out?
Yeah, I've mentioned methane hydrates. The essentially frozen methane. It's methane in ice cage. But in tundra and on the continental shelves, we have a lot of methane, enough to cause a huge global warming. And it has happened in the history of the Earth. In the Paleocene, Eocene thermal maximum, we got, if you look at the geologic record, it looks like we got a sudden spike of about 6 degrees Celsius global warming. And it looks like it was essentially instantaneous on that geologic timescale. Actually, it took a couple of millennia. And it probably was a melting of methane hydrates. The planet was getting warmer because India was moving through the Indian Ocean and plowing up these carbonates in the ocean floor and putting CO2 in the atmosphere. So the planet was getting warmer, and then it must have got warm enough that it melted the methane hydrates, and you got a sudden 6-degree warming. But that 6-degree warming was over a couple of millennia. I don't think now this methane hydrates gets a lot more scare stories than it warrants. You know, the previous interglacial was 2 degrees warmer than the pre-industrial 1 degree warmer than now. But that did not set off methane hydrates. And even some other interglacials before that were even warmer did not set off this enormous methane feedback. There is a positive feedback from methane, and part of that may have been from tundra methane, but it was an amplification of 25% or something over the CO2 warming. It was not a disaster type scenario that people are worrying about, perhaps excessively. We have plenty of reasons to be concerned about possibly causing ice sheets to go unstable and other things. But I think if we follow anything like the scenario that we're advocating, namely, begin to phase down our emissions, then methane hydrates are not likely to be a major player.
Right, I'm actually holding space for somebody else, so we'll just pass it over. Please go ahead.
Just one piece of information. We have a Boston Energy Forum that has faculty members from MIT, Harvard. We are concerned with the same issues that we deal with. Now, contrary to you, we are well connected to the federal government. some of our colleagues and friends are in the federal government, in the energy department. So, as a whole, we fail to convince them that you need to invest in new energy sources. But when you speak about nuclear energy, the technology is of 1955, something around there. There were some initiatives to do, besides what you said about fast reactors, with small modular reactors. They're just a pittance. The feasibility of fusion was not funded. You could have proved it was feasible scientifically. So somewhat, I think between your groups and our group, we have to get together and try to influence the government. I think we can do it directly, but we have to work together.
Yeah. So
the government thinks that gas is the solution to present government.
Yeah. Well, he correctly points out that our government is not investing in energy R&D. The investment now is just a fraction of what it was a few decades ago. And it's desultory. It jumps from one thing to another, and something gets half done, and then it gets canceled. I'm just afraid. I mean, and we do have pockets of excellence. In the Department of Energy, if you look at all the different labs, there are some pockets of excellence. But I think it's going to, at this point, looking for the government to solve this is not the way to go. It's going to be private enterprise. And we have to give them the economic incentive by having this carbon price. And we have to free them even Bill Gates is funding the development of a specific fast reactor, traveling wave fast reactor, which I don't think is the optimum way, but we're actually at a point where maybe private enterprise, even though we don't have that economic incentive there of the carbon price, there's still, in his case, he realizes that the planet is in trouble and young people are in trouble if we don't get some clean energy sources. And he poo-poos solar panels and windmills. The government is just too damn slow. And it becomes, and once you've got civil service system, it doesn't work so well. I know I was in the government and I see that laboratories become big and they have a $2 billion budget and they can keep that budget because their senator has clout in Washington. And so regardless of their productivity, they keep their budget. And agencies that were once very productive are become less productive. So we really need the competition. We shouldn't be giving people salaries for life. Governments have a role, but the R&D now, especially because it's got to be done rapidly, I don't want to say completely that government shouldn't be involved in that, but it has this handicap that it just has not been very effective. But we have the potential to do much better, and the best people don't want to go to work for the government.
Hi. So I have a question. So a lot of things that you've mentioned a lot about how we can try and stop further increases in carbon concentration in the atmosphere. But with the amount that's already in the atmosphere and the processes you already talked about with ice sheets melting and possibly sliding into the ocean, and then with the impacts that are happening on species and sea level expanding, et cetera, et cetera. I guess my question is, could you talk a bit about adaptation, or what you have to do, even if we manage to put in place all the policies that we want to stop the increase and level out our carbon emissions? What do you think that we're going to have to adapt to, and how do you think we might be able to do that?
Well, I don't emphasize adaptation because some of these things, extermination of species and ice sheet disintegration are, as I say, irreversible and dramatic impact. But of course, you can adapt to some of the humans can adapt, but I prefer to emphasize the mitigation and adaptation is something that is going to have to occur, but we have to minimize the amount of it. And I'll leave it to other people to focus their studies on adaptation. But some things, you just can't adapt to. Sea level rises and your island disappears and you can move. That's one adaptation.
So I apologize to the rest of the people queuing up. We have a reception meeting following this, so I'd like somebody to join us there. I'm going to take my moderator prerogative and prerogative as a young person to ask one final question. You're speaking to a lot of MIT students right here and a lot of young people. What should we be doing about the climate crisis?
Well, I mentioned one thing. Young people do need to make clear that they care about it. I gave the example of this trial. I hope that young people show up at it, and so the judge realizes, the judges realize what's at stake. You can be part of this, trying to influence the government in the democratic systems. Young people actually have enormous potential. And a good example was the thing that one of the things that dragged me back into the public aspect of this was after I had objected to Bush administration preventing me from speaking out, I then was invited to give a talk at Virginia Tech, and the students there then introduced me to Larry Gibson, who was refusing to sell his land on this mountain, so he was blocking the mountaintop removal. But those students at that university were working very hard for Obama. And I know that in Iowa, which is a state where suddenly Hillary was supposed to win that, and they ended up Obama winning the Iowa caucuses. It was largely because of young people. They were just out knocking on doors in tremendous, unexpected impact. And then Obama was elected, and the young people didn't know what they were supposed to ask of him. And if they did, and I argued, with the 350.org people, I argued, it's not enough to say Waxman Markey, cap and trade, that's not sufficient. But it is demonstrated that young people can impact the political process in a big way. And young people know how to use the social media things. And I'm skeptical about whether we can get these two parties to come off their extreme perspective. So I think we may have to think about a third party, which should be not one of these extreme Green Party or extremes. It should be a centrist party and advocate, taking advantage of the tremendous potential that we have in this country, and it should, in this energy situation, because it's so crucial for the economic well-being and for everything, it should be a center part of the policy, and have a country which is based on have a party that's based on the principles that our founding fathers advocated, which we've gotten away from in large degree. So I think young people are going to have to figure that out, the politics of this. the old geezers are not doing it. We screwed up and haven't figured out a way. We just have these two parties. So unfortunately.
So on that happy final note, we'd love to invite everyone to join us in the booth room, which is room 10105. It's directly below this room.